Today, we're going to talk about the most dramatic period in the history of physics since the time of Galileo and Newton that led to this. It was a week long gathering in Brussels from the 24th to the 29th of October 1927, also called as the Fifth Solvay Conference. Over here, you can see Albert Einstein, who seems a little ill at ease, and on this side is Niels Bohr, who has a half whimsical smile on his face. There is an ongoing debate between these two and so many of the others about the ultimate nature of reality. So, what is so dramatic about this gathering? By the end of the 19th century, many of the world's leading physicists were of the opinion that physics has already been established and most of the fundamental laws and constants have already been discovered, and the only discoveries that are yet to get uncovered lie within the sixth place of decimals. Albert Michelson in 1899 said, "Our future discoveries must be looked for in the sixth place of decimals." They believed that any new findings will only be supplemented to the existing physics that has already been established and will not be a challenge or a complete replacement of the physics that has been proven till date. James Clerk Maxwell, however, was against this kind of complacency and he warned about it in as early as 1871. So, what is the very simple question that led to the quantum revolution? In the mid 1890s, many of the Germany's leading minds were trying to solve a very simple, humble, and unglamorous kind of problem. What is the nature of relationship between the temperature, the colors, the range of colors, and the intensity of light emitted by a hot iron poker when you keep it in the fire? Now, this is a very unglamorous problem as compared to solving radioactivity or X rays that had physicists reaching out for their notebooks. Now, as simple as this problem sounds, many of the world's leading physicists could not solve it. In 1896, they believed they had solved it, but later on, more experimental data turned out to prove that they had not. In 1900, ultimately, Max Planck solved this, and he himself described the solution as an act of desperation and paid a very hefty price for that solution. And this solution put Albert Einstein very ill at ease, and from there on began the breakdown of classical physics and started the quantum revolution.